Application in Kinematics, presented to you by Mr. Kamanga. Welcome to this lesson. In this lesson, we are going to cover application in kinematics. This is application is in integration, is in relations to movement. Kinetic is a study of movement. So we can say change in distance with time gives us velocity through differentiation. So when you cover differentiation, you learned that if you are given an expression s is equals to 5t squared plus 2, then if we differentiate ds over dt, we get it is equals to 10t. So this is velocity. So velocity is equals to the differentiating ds over dt. Again, change in velocity with time gives us acceleration. For example, if you are given velocity is equals to t squared minus 3t plus 6, then we can get acceleration. It is equals to, acceleration is equals to change in velocity with respect to time, that is dv over dt. So from there we differentiate our expression of v. So this will give us 2t minus 3. So that is how we get acceleration, by differentiating the expression of velocity, or we say acceleration is a change in velocity with time. Since we have said integration is a reverse of differentiation, it implies that if we integrate acceleration, we should get velocity, and if we integrate velocity, we should get distance. The following diagram illustrates clearly what we mean by this statement. So differentiation with respect to time. When you differentiate displacement with respect to time, you get velocity. Then when you differentiate velocity with respect to time, you get acceleration. And we have said that integration is the reverse. So in integration with respect to time, when you integrate, since we are now going reverse of differentiation, when you integrate acceleration with respect to time, you get velocity. And when you integrate velocity with respect to time, you get displacement. So that is what we'll be covering in this topic or in this lesson. And now we are going to do a few examples and see how we apply this knowledge. You can advertise here. Just call us on 0725 357594. Thank you. So our example 1, a ball moving in a straight line passes through the point with a velocity of 6t minus 3t squared into bracket meters per second. Find an expression for its displacement s from this point, given that s is equals to 10 when t is equals to 0. So here we have been given the velocity, and we have said that velocity is equals to differentiation of s with respect to t. So ds over dt is equals to 6t minus 3t squared. So this means that if we integrate, that is the reverse of getting the velocity is to integrate. So distance is equals to integrating the velocity, so that we go back. Remember the diagram we had, to go back to displacement, which is the same as s, we integrate. So it is 6t minus 3 t squared, we put the bracket, this is with respect to t, not x, with respect to t. So when you integrate this, you get s is equals to, this is 6t, we will say it is 3t squared. That is, we add 1 to t, which is to power 1, and we divide by 2. So 6 divided by 2, that's where we are getting 3, minus, here we add 1, so it will be t cubed, divide by 3, so the 3 and 3 will divide, so we will be left with 3 cubed plus c, that is a constant. Now, we are given that s is equals to 10 when t is equals to 0. So we substitute these values so that we get our expression of s. So we say s is 10 is equals to, this is 3 multiplied by 0 squared, which is the same as 0, minus 0 cubed plus c. So this is 0, this is 0, and therefore our c is equals to 10. Now we can write our s, that is the expression for displacement, and say our s is equals to 3t squared minus t cubed plus 10, which is our c. So that is how we solve that problem. So we can say now that we have applied. We say that integration is the reverse of differentiation, and when you differentiate an expression, this expression was the expression for velocity. To get velocity, you differentiate 6t. When it was differentiated, you got 6t minus 3t squared. So if we integrate this, then we'll go back to displacement, which is we are getting as this expression. And therefore, when you simplify, since we have been given extra information, and that is when s is equals to 10, t is equals to 0, we are able to get the correct expression. So that's how you work out that problem. You can advertise here. Just call us on 0725 35 7594. Thank you. So in our example 2, a soldier fired a bullet upward at a velocity of 70 meters per second. Part A, Roman number 1. Find an expression for an expression in terms of t for its velocity. So we know that since the bullet is moving against the gravitational force or acceleration, then we can say acceleration of the bullet is minus 10 meters per second squared. So we also know that acceleration is change in velocity with respect to time. This means that if we integrate velocity, if we integrate acceleration, it is equals to velocity. That is, we integrate acceleration with respect to time, then we will get velocity, which we are required to get here. So to get velocity, then we will get velocity is the integral of minus 10 with respect to time, and this will give us minus 10t plus c. That is the velocity. So we need to find t. So we say that before the bullet started moving upwards, at t is equal to 0, the velocity was 70 meters per second. This means from our expression, v is equals to minus 10t plus c. We substitute, so v is 70, the velocity which was fired upward is equals to, time is 0, so this is minus 10 multiplied by 0 plus c. So you find that 10 minus 10 times 0 is 0, and therefore our c is equals to 70. This implies that the velocity is equals to, now we substitute our 70 in place of c, it is minus 10 t plus 70. So that is how you work out part A, Roman number 1. So part B, its height above the firing point. So in part A, we have found that velocity is equals to minus 10t plus 70. Now, when you are given velocity, if we get velocity by differentiating displacement with respect to time. So it means if we integrate velocity, we will be able to get displacement. So displacement is equals to integration of 10t plus 70 with respect to time, that is dt. When you integrate that, you'll be able to get, this will be t squared. So we divide by 10 by 2, so we have minus 5 t squared plus, this is a constant, so it will be 70 t plus c. Now since we are required to find the height above the firing point, we know that when t is equals to 0, that is before the bullet was fired, it had not covered any distance, and therefore s is equals to 0. This means that c, if we substitute this, then s is 0 is equals to minus 5 multiplied by 0 squared plus 70 multiplied by 0, which is our t, plus c. So when you compute, you find that c is equals to 0, and therefore the displacement s is equals to, now we write our expression, it is minus 5 t squared, since t squared plus 70 t, since our c is equals to 0. So that is the displacement, that, or the height above the firing point. So part B, find the velocity and height after 3 seconds. So we already got the expression for velocity and the height or the displacement. So we can start, so part B, Roman number 1, t is equals to 3. So we just substitute in for velocity, v is equals to minus 10 multiplied by t, which is 3 plus 70. So this will give you minus 30 plus 70, and therefore velocity is equals to, after 3 seconds, it is 40 meters per second. Then we look for the height. S is equals to minus 5 multiplied by, time is 3 seconds, so it's 3 squared plus 70 multiplied by 3. So this is equals to, 3 squared is 9. 9 times minus 5, you get minus 45. Then plus 45 plus, now this is 70 multiplied by 3 is 210 and when you subtract, you get 2010, you subtract 45, so you get this is 5, and this is 20 minus 5, so it is 165 meters. So that is the height after 3 seconds. Roman number 2, t is equals to 4. Then you say velocity is equals to, now we substitute in our expression for velocity, minus 10 multiplied by 4 plus 70. So this is equals to minus 10 times 4 is 40, minus 40, so this will be 30 meters per second. Then height is equals to, after 4 seconds we substitute, it is minus 5 multiplied by t squared, which is now 4 squared, plus 70 multiplied by 4. So this is equals to, you multiply, this is 16 multiplied by 5, that should give you minus 80, plus this is 280. So when you subtract, the height or the displacement is 200 meters. So that is how you work out part B of this question, and you'll be able to get the various, the velocity and the displacement after 3 and 4 seconds. Part C, find the turning point of the bullet. Now in this part, we know that at turning point, so that turning point, the velocity here is 0, and therefore when the velocity is 0, we can find time. So we have velocity is equals to minus 10 t plus 70. So if velocity is 0, then it means this is minus 10 t plus 70. We take minus 10 t to this side, becomes positive. So 10 t is equals to 70. Divide both sides by 10. Divide by 10. So we divide by 10. We divide by 10 there. So we have t is equals to 7 seconds. So it is after 7 seconds that the bullet will turn and then start moving downwards. So we find S as t at t is equals to 7. So our t is minus 5 from this expression here. So we multiply by, now it is 7 squared plus this is 70 multiplied by 7. So this will be able to get, it is equals to minus 49 times 5 is minus 245 plus this is 490, and when you subtract 245 from 490, you get 245. 245. So here we have 5. These are meters. So what this means is that the bullet will turn, since it was moving upwards, it will turn downwards after 7 minutes, after 7 seconds, at a height of 245. And that is how you work out that question. So that brings us to the end of our lesson. So after this, I'm going to give you an exercise for you to try and see whether you are able to work out questions on the application of integration in kinematics. So I hope you have enjoyed the lesson, and try and do the exercise. I'll provide for you the answers at a later time. So you are all welcome to our next topic. You can advertise here. Just call us on 0725 357594. Thank you. You can advertise here. Just call us on 0725 357594. Thank you. To get complete DVD of this topic and other topic, call us on 0725 357594. This is Teacher Wamta Productions. Mobile number appearing on your screen, my email address, and you can visit my YouTube channel Teacher Wamta for more topics and revision.